Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend.
Yeah, and that's me, wanting that. I'm Corinne Caputo, a funny writer and person. You get it.
Sometimes that's just how it is. Yeah. Hey, Corinne. I am Dr. Moiya McTier. I'm a space person and a myth person. Mm-hmm. Those are two of my greatest loves.
Real person.
And I am a real person. You can pinch me. I exist. And I'm also a friend to the universe.
Yeah, you are. You're one of the closest friends to the universe that I know.
I like to think so. I don't want to claim that I am the universe's best friend, but the universe might be one of my best friends.
I love that. There's a line in Severance, which if you haven't watched, you have to, where he says, "I'm your best friend. You're my very good friend." And I think that's so funny.
Burn. I just burned myself on behalf of
your best
universe.
friend. You're my very good friend.
You're my very good friend. That's awesome. Okay, yeah, so today we're talking about another subject in our good buddy, the universe. And that subject is very well reflected in our location. Corinne, we are in Rome. We are just to the west of the Roman Forum in the Temple of Saturn.
Oh, of course we are.
I actually did not want to meet any ancient Romans, and so I did not toggle on the time travel aspect of our transport machine. So we are at the Temple of Saturn as it is now. It is a ruin. There are many tourists walking around. It's a gorgeous day. The breeze is giving us some much-needed respite from the Italian summer air. And we are sitting in the shade, in the grass, next to this very, very old rock.
Yeah, I'm really glad that we're here today. It's beautiful out. I have a lot of sunscreen on, despite being Italian.
I also have a lot of sunscreen on because it doesn't matter how much melanin you have. You should use sunscreen anyway.
Especially with your tattoos.
Oh, yeah. And actually, I just got a new one. I now have a brand new leg tattoo, and I'm not allowed to put SPF on it. So I am wearing long, flowy pants.
Is that... I didn't know that was a rule.
Not until it's healed. Like, it's an open wound, you know?
That makes sense.
SPF has some harmful chemicals in it that are fine for closed skin, but yeah.
Well, I'm really glad we're here today to talk about this.
Yeah, mix some mythology in with the science because, as I said at the top of this episode, those are two of my greatest loves. In case you haven't figured it out, today we are talking about Saturn, the planet, while we sit here in the house of worship for the god that the planet itself was named after.
Yay!
Yay! Thoughts on Saturn, Corinne, before we get started?
Saturn to me is kind of like an in-between planet of, like, in terms of my interest level. Like, it's not the biggest, but it does have the rings, so I know, so it's higher than it could be, but it's not as, like, niche as Pluto or, like, we're gonna go to Mars. Maybe I should rank them all.
If you had to compare Saturn to, like, a state, which state would it be?
Ooh, that's such a good question. I think it's Washington State for me.
Oh.
Because it's like, I want to go there, but, like, it's not the first place I'm going to go.
Corinne, you're a genius. Thank you for that.
Thank you. Thank you for that.
Today we are talking about Saturn, the Washington State of planets. Just a perfect comparison.
In terms of size and rings.
So at first I figured it'd be a good idea to talk about the history of the study of Saturn. Much like with the Jupiter episode that we did a couple months ago, we can't pinpoint a discovery date for Saturn because it continues to be visible to the unaided eye. This was one of the 7 wandering stars that the ancient Babylonians saw, the others being Sun, Moon, Jupiter, Venus, Mercury, Mars, but this was the most distant one. It was the slowest of all of the wandering stars, and so it was associated with time because it just moved through the sky so slowly, which I think is an interesting way that our ancient ancestors used to look at the night sky and read into its behavior. it was incorporated into mythologies around the world, just like the other wandering stars. And when you look at how the Babylonians talked about it, they would often describe it as a black sun or the sun at night. And anthropologists are still trying to figure out why they called it black. I mean, it like has more of a yellowish color when you look at it in the sky.
That feels like a horror movie waiting to get written. Like that's, you know, like when a horror movie, like in Act 2 or whatever, the justification is like something bizarro like that to me is.
Oh my God, I love it. Corinne, you could write this horror movie.
Yeah, maybe I
should.
It.
The horror comedy genre, I feel like, is
a good
strong
one
right now.
Yeah, it is. Yeah. I do think I would get too scared writing it. I think I would scare myself.
So cute. So obviously different cultures did not call it Saturn. That was the Roman god, Saturnus. He was a god of agriculture and time, and he was pretty much the Roman equivalent of the Greek Titan Kronos, who was Zeus's father. The ancient Babylonians likely associated this planet with time because it moved so slowly, and that association was carried as the Greeks and then the Romans adopted mythology around this planet. So that's all the old stuff. But then we started to actually observe it with astronomy in mind, thanks to our good pal, Galileo. In 1610, that's when he first observed it through a telescope. And he saw two dark objects on either side of Saturn, and he assumed that Saturn was a triple body system, so like the planet maybe with two moons around it. But as he observed it year after year, he noticed that those moons would disappear and reappear every couple of years. And I imagine it must have driven him crazy. Like, why is it sometimes there and why not?
Yeah.
And he didn't realize it, but he was actually seeing the gaps between Saturn and its rings. So, like, those empty spots just looked like dark blobs next to Saturn.
Fun. Okay.
Yeah, just the trick of the eyes. Because it was the first telescope, and it was a pretty shitty one.
Yeah.
So then 49 years later, in 1659, there was telescopes were better, and this Dutch astronomer, Christian Huygens, observed Saturn through a better telescope and noticed that instead of two moons on either side of Saturn, it was actually a thin, flat ring that was like a solid ring around the planet.
That would have been shocking to me. That would have scared me, I think. Just to see a ring.
To learn that there were rings?
Yeah.
Yeah, I get, because we are used to having a moon. We know what that's like. But that must have been a very new concept. Like,
to see that for the first time.
Planets have rings?
Nobody believes you. Yeah, you're a witch.
Ooh, yeah. Luckily, he was not a woman.
Yeah,
and
good,
so
and lucky for him.
it was less likely that he would be tried as a witch. Not impossible. They tried some men.
Yeah.
But yeah, so he sees that it's a ring. Completely rocks the scientific community, I'm sure. And then a few years later, in 1675, an Italian scientist named Jean-Dominique Cassini, a name that might sound a bit familiar.
I do know that name.
To
I'm
fans of
why.
Saturn. Yeah. Oh, you'll hear about it later. So this Italian scientist Cassini discovered that it's not just one continuous ring, but it is in fact multiple rings that are arranged in a plane around Saturn. And he discovered specifically a gap or a separation that they call the Cassini gap, or like the Cassini discontinuation or something. That's 1675. And then we're not doing much with Saturn for a while. Every once in a while, maybe we'll discover a moon. But in 1859, James Maxwell, who was this physicist who was really interested in light. Maxwell's equations come from him, and some other theoretical physics things. And so he was theorizing about rings out in space, and he was pretty sure, based on pages of calculations, that a solid ring would be unstable. It should be ripped apart due to gravitational influence from the planet and maybe other moons that it has, maybe even other rings. Instead, they should be non-rigid rings. They should be made up of individual smaller particles. And in 1895, that was proven to be the case. A man named James Keeler found that the rings are indeed made of individual particles of like ice and small rocks. And he confirmed that using spectral data taken with the 13-inch refractor telescope at what is now the University of Pittsburgh. Shout out to Pittsburgh, which is where I was born. And he used that telescope to study the speed of the rings as they move around Saturn, and he found that the inner edge of a ring moved faster than the outer edge. So, like, they were moving at different speeds because they were actually many small pieces moving together as a whole and not one large, rigid piece. He then wrote about this finding in the Astrophysical Journal, which is today one of the most reputable astronomy journals in the entire world.
Wow.
And he co-founded it. So he co-founds this journal, and then he publishes in it. And then just more interesting stuff about James Keeler. He dies at the age of 42 because of, and I quote, a weak heart, according to the article that I read. And he had his ashes interred at the Allegheny Observatory where he made that discovery about the rings.
Wow.
Yeah. Interesting guy.
Cool for him. That's amazing to found a journal that is still, respected and widespread. And
yeah. I have never published in AppJ. That's what the cool kids call it.
AppJ. Wow.
In AppJ, because you have to pay to publish in AppJ.
Sure, of course.
No. All of my papers were published in the monthly notices of the Royal Astronomical Society, which does not make you pay.
But that makes you fancier.
Yeah. I wonder if James Keeler had to pay to submit his article.
Let's get to the bottom of that.
To his journal. Yeah, so that's the historical study of Saturn. I'm going to get to the missions that we have sent to Saturn later in the episode, but first I want to talk about its characteristics, because we know a lot about Saturn. Many people would say that Saturn is their favorite planet, and that's because it has a lot going on. It's a very distinct planet in our solar system.
Yeah.
So let's get into it. Some quick numbies on its orbit. The planet orbits 9.5 astronomical units away from the sun, so 9.5 times as far as the Earth. Or, if you think better in miles, that's about 886 million miles on average.
It is so far.
It's really far. It takes Saturn like 29 years to orbit the sun. Wow. A very long time.
Saturn's return. Duh.
Saturn's return.
When you turn 29, Saturn is supposedly back where it was when you were born, and you're going to go through something awful. For me, it was COVID.
Oh, that's one hell of a Saturn's return.
Me and everyone else in the world, as if I experienced it independently of everybody.
Oh my God. What if the 2024 election is my Saturn's return?
No, Moiya, it'll be something fun and better.
Okay. My something terrible will be fun and better. Thank you. So every 29 years, Saturn makes an orbit around the sun, but its rotational period, so its day, is much shorter. It takes only about 10.5 hours for Saturn to rotate once. It's quite fast.
Wow.
You are not wrong.
Hold on tight.
It is tilted, very similar to how Earth is. It has a 26.73 degree tilt, so it has seasons, just like we do, but each of those seasons last 7 years. And it also has a fairly circular orbit. Its eccentricity is just a little bit higher than Jupiter's at 0.054. So hopefully all of those numbies will give you a sense for the shape and size of Saturn's orbit around the sun. But now, some information about the planet itself. It is 9 times wider than the Earth. You could fit about 750 Earths inside Saturn, not including the rings, just inside the gaseous envelope. So it's 750 times more voluminous, but it is only about 100 times more massive than the Earth, because it's mostly made out of hydrogen and helium. It's a gas giant.
Okay, so it's not as dense.
It's not as dense, not nearly. But if you do out that math, if you divide the mass by the volume and get the density, then you find that Saturn is actually less dense than water, and it is the only planet in the solar system that is, on average, less dense than water. So if you found a pool big enough, it would float on a pool of water.
Like a beautiful, floating, tube. Oh, I love that.
Yeah. Exactly. Similar to Jupiter, it has a solid core beneath the big gaseous atmosphere, and it also has a layer of metallic liquid hydrogen, but that layer is much thinner than on Jupiter, and it does contribute to the planet's magnetic field, which is, again, weaker than Jupiter's, but still hundreds of times stronger than the Earth's magnetic field.
Wow.
Quite big. That magnetic field helps create aurora. So you can see aurora if you go out to Saturn. And we had a whole aurora episode here at Pale Blue Pod, but that was specifically about aurora on Earth, which is what you get when charged particles from the solar wind, from the sun, interact with our Earth magnetosphere and get carried by the magnetic field lines to the poles. Saturn has this really special thing going on where the charged particles that create the aurora do not come from the sun. The sun is too far away. So some particles get there, but not enough to create aurora. And also, unlike the Jupiter system, most of the charged particles are not coming from other moons and landing on Saturn. Saturn creates its own charged particles through wind movement in its upper atmosphere, and that is how it makes its aurora.
Fun.
So it's self-sustained ultraviolet aurora. You can only see them in UV
Beautiful.
rays. Beautiful. Yeah. And that information about the wind causing the aurora, that is brand new. That's from a 2022 study in the journal Geophysical Research Letters, where they were using spectra to study the winds in Saturn's upper atmosphere. But those same charged particles that create the aurora, they also made it difficult to accurately measure Saturn's rotation rate for a long time.
Oh.
So our measurement would oscillate between 10 and 11 hours, but we nailed it down, and it's closer to 10 hours, 33 minutes.
Cool.
I love thinking about other planets and their magnetic fields, because our magnetic field is so important for our survival.
Yeah.
Yeah. I just like thinking about it. Not that we should be thinking about life forms like us surviving out around Saturn. It is way too cold. The average temperature on Saturn is negative 220 degrees Fahrenheit.
No, too cold.
Yeah.
No, thank you.
That's a big no. It's a big no.
Yeah, it's never
No matter
gonna
how
work.
many jackets you wear.
It's never gonna work.
No amount of layering will prepare you for that low of a temperature. But of course, the temperature is different at different levels of the atmosphere. So as you get further down, the pressure and the temperature will increase to a point where you can take these gases and turn them into liquids, like liquid hydrogen. The winds that produce those same charged particles for the aurora, they move real fast. The maximum wind speed that you would find in Earth's upper atmosphere is around 240, maybe 250 miles per hour. In the upper atmosphere of Saturn, they get to 1,100 miles per hour.
Wow. This planet is doing the most.
It really is. It's so extreme. And we can't talk about Saturn without talking about the moons, right?
Yeah.
It does have, as far as we know, the most moons in the solar system, with 146 known moons.
Wow. That is so many.
It's a lot. But only about 60 of them are named, according to the International Astronomical Union, or the IAU. All of these moons range in size from a sports stadium. So anyone who has been to a Beyonce or Taylor Swift concert.
I was going to say the Beyonce show.
Yeah. I literally was not going to use a sports game for this comparison. Anyone who has been to one of these mega tours, you have been in a space, you and all of those thousands of other people were in a space bigger than some of Saturn's smallest moons.
Wow. Yeah, it is
never gonna
Beyonce
do, the Super
Stadium.
Bowl.
Yeah, it's Beyonce Stadium, and the sports people are renting it.
Truly. But then the biggest ones are bigger than Mercury. So some of Saturn's moons are bigger than the smallest planet in our solar system.
Oh, wow.
Yeah. And like all of the planets in our solar system, Saturn has a naming convention for its moons. Originally, they had all these different names because they were found by different people who would name them whatever they wanted. But then in the 1800s, John Herschel was naming some of them. This is the son of William Herschel, who discovered many of these moons. But John Herschel named the
Nepo
first
baby.
moons.
Nepo
Yes.
baby.
Oh my God! Yeah, one of the first astronomy Nepo babies. Oh my! I can't unhear that now. You just...
I'm
you
cracking
just
this wide
destroyed my
open.
brain. Damn it, Corinne. So this first Nepo baby, named the first moons that were discovered, the first 7 moons, after titans and giants from Greek mythology. And his justification was, quote, "As Saturn devoured his children, his family could not be assembled round him, so that the choice lay among his brothers and sisters, the Titans and Titanesses," end quote. And that's because in mythology, the Saturnus character, who was based on Cronus from Greek mythology, ate all of his children.
Yes. I know the iconic painting of
Yes.
Saturn
Oh, the
eating his children.
devourer.
Yes. Mm-hmm. And I saw, there's a really funny tweet or something that says, "Don't talk to me until I've had my son."
Oh, that's so good. Oh, that's so good.
Yeah.
So Saturn, or Kronos, eats his children, but is tricked by his mother and some of his siblings so that he spits them up. And those are the Olympian gods who then overthrow Kronos and the other Titans. And so John Herschel names the moons after Titans and Titanesses. But then in the late 90s, early 2000s, we discovered a shit ton of new moons around Saturn. And the IAU really needed to expand its naming, the pool from which it could pull names.
Yeah.
And so in 2004, the IAU opened its naming scheme to include giants and monsters from
Great.
other mythologies like Norse and Inuit mythology.
Yeah, that seems like that'll immediately open it up.
Exactly. Like, oh, we found 100 new moons. You know?
Great. Name them after monsters.
Hesiod only wrote about so many titans, right? Like, so we needed to expand it. And because I'm not going to talk about it later when we play our game, Corinne, I do need to talk about one of the moons now. So Saturn's biggest moon, do you know what it is? Have you perhaps heard of it?
I have heard of it. It's Titan, right?
Yeah.
Yeah.
Yes. Titan is big chunk. It's a big moon. It is the second largest in our entire solar system. Jupiter's Ganymede is only like 2% bigger than it. It is indeed bigger than the planet Mercury. So lots of surface to deal with. It even has its own atmosphere that astronomers have been fascinated by for decades. As far as we know, it is the only other world in the solar system that has standing liquid features like oceans, rivers, and lakes on its surface. We found subsurface liquid, but it's just chilling there on the top. It is, however, not water. These oceans and lakes are made of methane and ethane, but still liquid, pretty sick. The atmosphere on Titan is about 5% methane and about 95% nitrogen. So it's quite dense.
Yeah.
Our atmosphere is like 78% nitrogen. So Titan has a pretty thick atmosphere, and it has a liquid cycle. It's like we have the rain cycle of evaporate, condense, precipitate. They have that, but with methane and ethane rain.
Whoa, like a very kind of alt universe, different timeline thing. I just Googled a picture of Titan to see what it looks like. It does look like a hazy Earth, kind of. Well, there's some that it's like mostly yellow, but then there's a few pictures where it looks like it has clouds and land and ocean. And the title of the article is Confessions of a Planetary Scientist. Quote, "I do not want to live on Mars." And I'm sure it's about like, well, what if we go to Titan instead? But that's so funny.
But, okay, you're joking. But yes, there are schools of astronomers who will debate like where we should be focusing our attention in the search for life. And in the last decade or so, the Titan people have gotten very loud.
Yeah.
So loud that just a couple of years ago, they were awarded a mission to go specifically to Titan, and it beat out a mission to Mars and I think a mission to return to Venus. So yeah, Titan is big.
I mean, based
astronomy.
on looks alone, I think I might be Team Titan.
I think I'm also Team Titan.
Yeah.
Team Titan.
Teen Titans.
So we've talked about like the formation of our moon. And in that episode, we talked about the different ways that moons can form. We've been interested in studying that for other moons in the solar system, including Titan. And some chemical analysis of Titan's atmosphere suggest that it didn't form around Saturn, but instead perhaps formed like in the Oort cloud, which is a big collection of rocks and comets and stuff outside the orbit of Neptune. Because its composition, all of that nitrogen and stuff, it looks a lot like other things that we have found from the Oort cloud. So maybe it formed there and then was captured by Saturn's gravity.
Cool.
Which might explain why it's so big, too.
Yeah.
So that's moons. We're going to talk more about moons later, but it's time to talk about the rings.
Let's do it.
Hey, fellow universe friends, it's Moiya here. Corinne very kindly offered to take pictures for a group of tourists, and now she's stuck with a whole line of people. And that'll teach her to be so nice, but it does give me time to thank our patrons who support this show every single month. So thank you, as always, to our sun-like stars, Lissa and Peyton. I hope each of you have a surplus of ringed planets orbiting around you. You, too, can support us. You can hear your name on the show, and you can make it to our patron star chart all by supporting us on Patreon for just about $1 per episode. And if you sign up for an annual membership, this is something new we just started to offer, you get a 13% discount across an entire year. That is 1% for every constellation along the ecliptic. You can find our star chart, Patreon info, and more at our website, palebluepod.com, or just go right to patreon.com/palebluepod. Of course, that link is in this episode's description. And if you can't support us financially, that is totally fine. You are still space, the universe still loves you, and so do I, because there are other ways that you can help support the show. One is to share us with your friends and family. Pick your favorite episode and send it to someone who you think would enjoy it. You can also rate and review us on your favorite podcast app of choice. I absolutely love reading your reviews. It gives me a little jolt of joy every time I see a new one. So please rate, review, share us with your friends. That's a great way to help Pale Blue Pod get even bigger and take over even more of the universe. All right, moving on. If you love the silly games that we sometimes play here on Pale Blue Pod, I think you're really going to enjoy Tell Me About It. Tell Me About It is another show in the Multitude Collective, and it's a game show about proving that the things you like are actually interesting. It's hosted by Adil Rafai, who you may have heard on Hello from the Magic Tavern or Hey Riddle Riddle, and of course Multitude's very own Eric Silver. Adil plays an eccentric billionaire who forces guests to come on the podcast and prove that their favorite thing is interesting and cool. And through a series of wild games and challenges put together by audio butler Eric Silver, guests are scored based on the quality of their answers or whatever Adil is feeling at the moment. You can think of this as podcasting Taskmaster, or as an in-depth conversation about something your friend is super into, mixed with hunting humans for sport. And the high scoreboard is filled with some of your favorites in podcasting. Janet Varney, Matt Young, and even me. I was on an early episode and Adil gave me like 1,000 points for explaining how cool exoplanets are. New episodes of Tell Me About It come out every other Thursday, and you can search for it in whatever app you prefer. Again, that's Tell Me About It, and it is the most fun podcast run by a multi-billionaire. All right, I think Corinne is pretending that her arm is too tired to keep taking photos. So she's walking back this way now, and that means it is time to get back to the episode. It's Saturn's most characteristic trait. You think rings, you think Saturn, even though Uranus is out there with its own little ring, but everyone's like, oh, no,
nobody cares.
Nobody cares. Nobody cares about the butt ring, you know?
Aww.
And so, so Saturn's really got a monopoly on ring discourse. Its ring system is the biggest that we can see. Its rings extend out like 175,000 miles. But they're only like 30 feet thick. They're really thin.
That is a lot.
Compared to how wide they are.
Thin.
Yeah, I never realized that they were quite that small.
Yeah.
In terms of their height. And they are arranged in bands that are labeled with letters in the order they were discovered, not like their order going out from the planet. Yeah.
Okay.
So like A was discovered first and then B. So it was Cassini who discovered that gap, and that gap separated out the A and the B ring. But now we've been able to see it in more detail. So starting from Saturn, going out, first there's the D ring, and then C, then B, and then there's the Cassini division, that gap. And then there's the A ring, the F ring, the G ring, and then the E ring. And then way outside of that, there's a very faint ring called the Phoebe ring, named after a moon that is like contributing and like maybe breaking up over time and contributing to this ghost ring, as some people call it.
Oh, okay.
Yeah. DCBAFGE.
That's not right, but
That's
okay.
not right. Yeah. So those are the rings. And then another feature that some people might think of when they imagine Saturn is that hexagonal storm at its pole. Have you seen those pictures?
I don't think I have.
Oh, there's this really cool storm similar to the Great Red Spot on Jupiter.
Oh, yes, I have seen that.
Yeah. Yeah.
It's like a very bizarre shape.
Yeah, it's an actual hexagon. Like there are sharp corners, and we saw that when we sent the Voyager spacecraft out, and it took the first pictures of Saturn. But we were able to study it in more detail with the Cassini spacecraft. But we know that storm is over 20,000 miles across.
Wow,
it's really big. And in a paper from 2020 that I read, it was described as a, quote, striking example of turbulent self-organization, end quote. And I like that because it truly is just like a random sequence of fluid dynamics and like atmospheric physics that produced what seems like a very intentionally crafted shape, but sometimes nature just be like that.
Yeah.
Yeah. And it produces something that seems very ordered out of what is actually chaos.
Yeah.
So it is a 6-sided jet stream. It's likely the result of a bunch of little cyclones or like vortices or essentially like little tornadoes that happen deeper in the planet's atmosphere. And as it moves up through the higher, less dense layers, those cyclones get pinched in a way that produces a hexagon shape. And no matter, I couldn't find any paper that would tell me like how or why it makes the hexagon. The furthest I could get was it pinches the vortices and then that makes the hexagon, which is my issue with scientific papers. They do not often go into that type of detail.
Yeah.
There's also a storm at the south pole of Saturn, but it looks just like a normal circular hurricane with an eye in the middle. So
who
something
cares?
About the North Pole is...
So get out of here, Storm. There's something way cooler happening over there.
Somewhere, like, there's got to be a story about, these storms being two siblings and one gets jealous of the other.
Yeah, there's a hot twin and a not hot twin in every...
Oh, yeah. Those are Saturn's characteristics. Did I leave anything out? Is there anything else you've seen or wondered about Saturn?
You've hit the highlights for me of what I remembered about Saturn. I am very interested in this moon, and I can't believe I forgot about this storm. If you're listening and you haven't seen it, you should Google it right now because the shape of it is very cool.
Yeah, like that does not look like something natural.
Yeah.
But it is.
Yeah.
All right, now I'd like to talk about the missions that we have sent to study Saturn. And there haven't been that many of them because Saturn is really far away and hard to get to. So, we haven't studied it as much up close as we have Mars or the moon. But we've sent a couple. The first were the Voyager spacecraft. So Voyager 1 and Voyager 2 were sent to study the outer solar system, specifically Jupiter and Saturn. And then they just, kept going to the outer solar system.
I always feel sad when I think about that. I'm like, what if they were trying to stop? They were trying to brake and they couldn't. I'm personifying objects, which is not healthy, but...
Yeah. Well, I like to think because they were specifically designed, I feel like they knew it was their destiny to go on that one-way mission.
Yeah, that's true. That helps.
They were literally built to be wanderers and adventurers, Corinne.
I like that. I like thinking of it like that.
So the first one passed Saturn in 1980, and then Voyager 2 passed 9 months later in 1981, and their flybys revealed a couple of cool things. This was like the first time we're seeing Jupiter and Saturn up close, even though it was like a very shitty 1970s, really. They were building it in the 70s, 1970s camera. So we learned that Saturn was mostly hydrogen and a little bit of helium, just like Jupiter. But we learned that it had a lower concentration of helium in the upper atmosphere compared to the lower atmosphere than we expected looking at Jupiter. And so they were like, maybe the helium is sinking to the middle. Maybe that's why Saturn is warmer than we expect it to be. Unclear. But they were able to see differences in the composition at different levels of the atmosphere, which is very cool. They measured the speed of winds at a few different levels of the atmosphere, and they noticed that on average, like more than half of the winds are flowing east. So there is some preference towards the east direction, although it does alternate a little bit, especially at higher latitudes. So like above 40 degrees, there would be bands that alternate between a west wind and an east wind and a west wind, back and forth. They also were able to measure the temperatures at different layers of the atmosphere by shining a radio light, like a radio beam, through the atmosphere when it was finally on the other side of Saturn. So like on the other side, shining it through at the sun. And then they were able to measure the amount of energy in different layers of the atmosphere to get a sense for how hot it would be. And they also saw the aurora in ultraviolet light for the first time. And then scientists were like, what is that?
Yeah, wait a second.
and then we studied the aurora again. So that was in the 80s. And then in the next decade, in 1997, we launched the Cassini spacecraft. It launched in 1997, took 7 years to get to Saturn, past Jupiter on the way, and studied the whole Saturn system from 2005 to 2007, even though it was only supposed to be operational for 4 years. So it had many mission extensions.
I love when that happens, and it seems like that happens a lot. So
a lot. Yeah, because NASA builds good stuff. Yeah. Actually.
Yeah, I mean, we're not at all thinking about all the ones that failed immediately or like exploded, but
when we send something
out,
when
it gets there, it does a good job. Yeah.
So in those 12 years that it was studying the Saturn system, Cassini orbited Saturn almost 300 times. And it would weave in and out of the moons, in and out of the rings, until eventually in 2017, I think it was just 1 month before its 20-year anniversary in space, they sent it careening into Saturn so that it would be destroyed and not contaminate the rest of the solar system.
Yeah.
We'll probably do an episode on the Cassini spacecraft, so we'll talk more about that then, but it did a lot. 300 orbits, 12 years. Think something like over 6 gigabytes of data taken, 5,000 research papers published with data from the Cassini spacecraft. It was a really monumental mission. It learned that Enceladus had liquid water under its icy surface. Enceladus is one of the moons in the outer solar system that we think might be a good candidate for extraterrestrial life. It saw that the rings change over time, especially the F ring. That seems to be one of the most adaptive rings in the Saturn system, because it was noticeably different when Cassini passed it than when the Voyager spacecraft looked at it. So just in 20 years, it changed drastically. They noticed that there are lots of meteor impacts out in the Saturn system, and that Saturn and Earth actually have pretty similar impact rates when it comes to asteroids and meteors. And it also sent a European instrument called the Huygens probe to study specifically Titan. So European Space Agency put the Huygens probe on Cassini, sent it out to the system. It was like hitching a ride. And then it went right to Titan, and it only survived for a few hours because Titan's atmosphere is really toxic and extreme. But during those few hours, it found all of those surface liquid features. It studied a little bit of the atmosphere and gave us a hint test that is probably the reason the Dragonfly mission was accepted. And Dragonfly is expected to launch in 2027. And one of the big things they're hoping to find is more evidence of prebiotic chemistry, because when Huygens went to Titan, it found some chemicals that are kind of like the very early building blocks of what could one day be life.
Oh.
So like, they're interested.
Fun.
Yeah. And there will be some other missions sent to Saturn in the next few years, but not by NASA, and not specifically to study Saturn, but more like the outer solar system in general.
Cool. Yay. Oh, I can't wait to learn more about Saturn.
Yeah, me too. I have a game for you, Corinne, but before we get to the game, do you have any questions about Saturn?
I'm curious about all of its moons, but there are so many of them.
So many.
So,
okay, well then let's talk about some moons, because that is what this game is all about. It's a return to the Match the Moons game that we played for the Jupiter episode. So I have selected 5 of Saturn's moons. That's 5 out of 146.
Okay.
I can't talk about all of them. But like I said, all of these are named after figures from mythology. And so I am going to describe the mythical character to you, and I want you to tell me what moon it is. And if you get it, or if you need an extra hint, I also have some information about the moon.
Okay.
For the audience, there are 5 moons in this round. In alphabetical order, the answers to this round will be Atlas, Enceladus, Iapetus, which I love to say, Mimas, and Tethys.
Mimas. I don't think I've heard of Mimas.
I tried to get some moons that not everyone would have heard of.
Yeah.
Yeah. All right, so Corinne, are you ready?
Yeah, I'm ready.
Okay, number 1. This is the Titan of freshwater and nursing mothers. She's the daughter of Gaia and Ouranos, and also the sister and wife to Oceanus. I'll let your mind wrap around that for a second. She is the mother to thousands of river and ocean gods throughout the world, and in some stories, she looks after baby Hera while Zeus is overthrowing their father Kronos in the whole, like, Olympian takeover of Olympus. And later on, when Hera wants to punish Callisto for sleeping with Zeus, she gets help from this Titan. Callisto, now a bear, which we talked about in the Jupiter episode, isn't allowed to drink or bathe in fresh water because this Titan forbids it. And the ancient Greeks used that to explain why the constellation Ursa Major never touched the horizon or dipped below it. Because, like, the bear could not touch the water.
Right. Oh, okay. That's fun. Yeah. I like that.
Yeah. So, who is this Titan?
Okay. It is impossible to distinguish for me the gender of any of these names, which is probably how all names should be, but is it Mimas?
It's not Mimas. I'll tell you a bit about the moon now.
Okay.
I don't know if that's going to help, but we'll see.
We'll try.
This is Saturn's 5th largest moon, and it actually has 2 of its own moons that it has caught through its gravity. And the astronomy community is split on whether those moons that orbit moons should be called moons or moons. I'm partial to moons.
That is so funny.
The surface features on this moon are named after characters and things from Homer's Odyssey.
Okay, my second guess is Enceladus.
It is not Enceladus.
Well, then I'm out.
Should I tell you the answer, or should I go on to the next one?
No, tell me.
I feel like I should go on to the next one so you don't get to eliminate them.
Oh, I was trying to trick you.
We'll come back to it. We're going to come back to it, Corinne.
I was trying to trick you into giving me the answer.
I'm becoming a harsher judge as we make more episodes. All right, let's see if you get this one. This second Titan is the Titan of mortality, or maybe, according to some sources, craftsmanship, ? He is the son, also, of Gaia and Ouranos, and the brother to Kronos. When Kronos overthrew their father, this Titan was one of the 4 to hold up Ouranos in place so that Kronos could castrate him. A very traumatic experience, I imagine. And he fought against Zeus in the Titanomachy. He is also the father to Prometheus and some others, one of whom is named on this list.
Tethys? Tethys? No. Oh my god, I have no idea.
This moon's claim to fame is that it is drastically two-sided. One side is much darker than the other. And for a while, that confused astronomers until we realized that it is, in part because it is tidally locked. So one side of it is always facing Saturn and one side is always facing away. But most of Saturn's moons are tidally locked. So the real explanation here for the differences in color is from, and I quote, unhappily, thermal segregation.
Oh my God.
Because the moon rotates so slowly, it rotates once every 79 days. And because it rotates so slowly, the dark side absorbs a lot of heat and holds onto it for a long time. So any like volatile chemicals will sublimate out of the hot ground and like travel over to the cold side. So it creates this like, on Earth, the rich get richer, and on this moon, the cold gets colder, you know?
Okay. I am going to say Iapetes. I got it right.
Iapetes, Iapetus, Iapetus. I don't know how you're supposed to say it. I like Iapetus.
Iapetus is easier to remember.
It is, yeah. And I feel very Southern when I say it. Iapetus. So yeah, that is Iapetus. Good job.
Cool.
But good job, you're 1 for 2. Okay. After the Olympians defeated the Titans, Earth Mother Gaia sent the giants to fight them. This moon is named after the leader of those giants, a son of Gaia and either Ouranos or Tartarus, which is like the personification of the deep, dark pit of hell. He fought against Athena, who overcame him and buried him under Mount Etna, and he was said to be the giant who shook the earth, responsible for earthquakes and the eruptions from Mount Etna, which is an active volcano off of Sicily.
Whoa, okay. I want to say Enceladus, because the name is scary, and earthquakes are scary.
Yeah.
Is that right? I mean, I'm sure that's not the justification, but that is so right.
I mean, you know, maybe you're just tapping into like the human collective psyche and understanding that Enceladus means like earth shaker. Yeah.
Well, to me, that's, of all these words, that's the word I would assign to an earthquake if I didn't know what it was.
Yes. I love that for you. It is Enceladus. Congratulations.
Yes.
Enceladus is Saturn's brightest moon and one of the brightest objects in the entire solar system. For those keeping track of astronomy buzzwords at home, that means it has a high albedo, so its surface is very reflective. And because it's so reflective, it doesn't absorb a lot of heat, which means the surface, very cold. In fact, it's a solid ice crust, and underneath that is, we think, a liquid water ocean full of salty goodness that could potentially create and host life. Some of the material from this moon, some of like that liquid water, gets ejected out through geysers that contribute to the E-ring around Saturn.
Oh, cool.
Yeah. And Cassini flew through those geysers and detected some potentially like organic material or whatever, and now we want to go back and study it further. Much like Europa around Jupiter. All right, good job. 2 for 3. Number 4. I think you'll know this one. This Titan led the war against the Olympian gods, unlike his brother Prometheus, who fought for Zeus. For this offense, he was forced to bear the weight of the heavens on his shoulders for all eternity, except for a brief respite during one of Heracles' labors.
Yes, this is Atlas.
Hell yeah, it is. Atlas, he held up the world.
My nightmare job.
Look, my posture's already bad enough, and I already hold enough weight with my anxiety.
Yeah, I'm holding enough.
I think you'll like this moon, Corinne. This moon, along with the moon Pan, has a distinct flying saucer shape. So it literally looks like a little flying saucer. I think you should Google it. You'll think it's cute. It has a rocky ridge that extends from its center.
I didn't know we could look like this. This looks so strange.
I know. It looks like it got jealous of Saturn and its ring. So it's like, well, I'm going to have my own little rocky ring.
It's like, well, I'm going to be this. This is so weird, this one.
It's so
Oh my
weird.
God, it's so funny. I think it's so funny.
I knew you'd like it. And it's small. It's less than 20 miles across.
Oh, we all gotta go.
Let's go. Class trip.
Let's go.
Class trip to Atlas.
It's a ravioli.
Oh my god, it is.
It looks like a ravioli.
It's the ravioli moon.
Yeah.
And it's not alone. I like that it and Pan are both this shape, because if it was just one of them, I feel like it might get lonely.
The lonely ravioli.
Like maybe
the children's book.
Oh my god, Corinne. If you don't write a children's book about the other moons making fun of this little ravioli until it finds the other ravioli moon, are you kidding me? Someone write this. Great job. You're now 3 for 4, I think.
And then I get a bonus point for the lonely ravioli.
Yes. Number 5. This giant fought against Hephaestus in the Gigantomachy and was ultimately defeated when the smith god pierced him with a hot metal rod. But in some other versions, he is smited, smote, smitten?
Smart. I don't know.
He is smart. He's smate.
He's
whatever the past version of smiting is, he was that, but by Zeus's lightning bolt. So which giant is that?
Okay, I have Mimas and Tethys left, right?
Mm-hmm.
I'm just going to say Mimas.
Yeah.
Yeah. Am I? Okay,
You're
50-50.
50-50, baby. Good job. Yeah, this is the smallest of Saturn's major moons. So it's pretty big. It's like 100 plus... No, a couple hundred miles across.
I feel like the name makes me think small, but if it's named after a giant, it feels inappropriate.
Yeah. Because Mimas, it sounds small.
Yeah.
It sounds wee.
Yes.
It is small. A couple hundred miles across is not big enough to be spherical, so it doesn't collapse into a sphere under its own weight. Its claim to fame, I guess, is that it's riddled with impact craters. Like, it's just covered in them.
It looks like the Death Star.
Its nickname is the Death Star.
Really? Oh, it
Yes.
looks exactly like it. Like that big hole.
Mm-hmm. So that big hole is called the Herschel crater. It's more than 80 miles across, and it does really make it look like the Death Star.
Yeah.
But there's no reason that this moon should get peppered with more asteroid impacts than any other moon, especially since it's it's not particularly close to or far from Saturn.
Mm-hmm.
And so the reasoning, we think, is that this moon is frozen solid. That means there's not like internal processes smoothing the surface over time. So it gets just as many impacts as other moons, but it
shows
preserves those marks. Yeah. And we're not totally sure why it's frozen, because it should experience some tidal stress just like Enceladus does. And so any model that explains... It's now called like the Mimas problem, where a model that explains the temperatures of these moons under different gravitational stresses has to be able to explain why is the core of Enceladus liquid, but Mimas is still frozen.
Yeah. Maybe it's actually the Death Star.
Maybe
and it's not a moon. Ever thought of that, scientists?
This is why I don't watch Star Wars. This is it.
That's the only reason.
So that means that the first one, the Titan of freshwater and nursing mothers, was Tethys. And Saturn's 5th largest moon.
The goddess of nursing. I didn't know we had one.
Yeah, the name translated from Greek is like grandmother or nursing. It has similar roots. Like a very nurturing figure.
She seems great.
Well, good job, Corinne. You got what?
Thank you.
4 out of 5.
Yeah.
Plus a bonus. For the ravioli.
Oh, I love it.
Well, it is getting to be evening. These summer Italian nights aren't exactly cold, but, just chilly enough that I would like to go get like an affogato
ravioli
or something.
Oh, an affogato. First savory, then sweet.
Oh, I like it. Let's get a whole meal. Second dinner.
I love it.
Awesome. But no matter how many dinners you have had today, please remember, you are space.
Bye.
Hey Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.